Hello viewers, welcome to my first lecture on soil mechanics. Today I will talk on weight-volume relationships of soil mass. Let's say we have a soil mass here of known weight and known volume. The weight of the soil mass is W and the volume of the soil mass is V. Now if you look at it very closely or microscopically, you'll probably notice that there are some solid particles floating around in this soil mass, and between the solid particles there are some void spaces. Now let us take an imaginary cylindrical basket and put all the solid particles into this basket as a lump. So the volume of these solid particles, let us denote it by V subscript S, and the corresponding weight on the left hand side of the cylinder by Ws. And the remaining portion of this cylinder would then be the void space, so we call it volume of void. And this volume of void, in this space we can bring the water between the void spaces here and put it here. So that would be your volume of water, and the corresponding weight would be weight of water. And in the remaining portion, it would be filled, the void space would be filled with air, and the volume is volume of air, that is VA, and the weight, corresponding weight, which is of course very insignificant, would be WA. So this is a three-phase presentation of a soil mass, and this three-phase presentation is very important for understanding the weight-volume relationships. In fact, the weight-volume relationships of soil mass comprise the backbone of understanding of your soil mechanics. So, soil is a three-phase element. It consists basically of two parts. One is solid part, that is this, and the void part. And void part, in fact, consists of water and air. So, to give you an expression of the total volume. See, the total volume of a soil mass consists of basically volume of solid and the volume of void, and the volume of void can be split into two parts, that is volume of water and air. And the weight expression consists basically of weight of solid, weight of water, and weight of air. Weight of air being insignificant, the total weight may always be taken as equal to weight of solid particles and weight of water only. So let us start with some definitions which involve weight-volume relationships. First of all, we'll see some relationships, that is volume to volume relationships, no weight here. So the volume to volume relationship, the first one and the very important one, is usually called the porosity of a soil mass and denoted by N, and is described or defined as ratio between the volume of void and the total volume of a soil mass. That is, how much space in the total soil mass is actually a void space. That is defined by porosity. And the range, typical range of porosity may be greater than 0 and less than 1. 0 means when the value of porosity is 0, that means it has to be 100% solid. You see, if there is, it will be 0 only when the volume of void is 0. That means it will be totally a solid soil mass, which is practically not possible to find. And the other extreme is, of course, the value of 1. That means it has to be 100% void. That means it is a hollow type of material. So that also does not exist in a soil mass, at least. So the range would be greater than 0 and less than 1. It cannot be equal to 0. It cannot be equal to 1 as well. So let us for better understanding or to develop more insight, and this is a very very interesting question. I always tend to ask this question to the students in the interviews, that if N is equal to 0.5, what is the percentage of void in the soil mass? So if you take the mathematical expression, that is n is equal to 0.5, that means it is 1 by 2 or 1 upon 2. So n is the volume of void by volume, which means uh, if total volume of the soil is 2, the volume of void in this soil will be equal to 1. So if you go back here, so this would give you volume is equal to 2, the total volume should be equal to 2, right? And the volume of void is equal to 1. That is the meaning of porosity is equal to 0.5, right? So what does that mean? That means the percentage of void in this soil mass, the total volume is 2 and the void space is 1, so the percentage is 50%. So 50% is void and the remaining 50% is solid. Okay, let us go to this another very important definition which involves volume to volume relationship. So the void ratio is the next definition and is denoted by E, right? And this is the ratio between the volume of void and the volume of solid. The earlier one was the ratio between the volume of void and total volume, but this one is between this and that. And the range, if it is equal to 0, it cannot be equal to 0, because if it is equal to 0, it means it is 100% solid. No such soil mass exists on Earth. And the maximum ratio can be anything. I mean, the upper limit can be less than 1, it can be equal to 1, and even it can be greater than 1. It depends on the presence of different percentage of solid and void. For example, it will be less than 1 when if the volume of void, this volume of void is less than the volume of solid. Okay, in this case it doesn't show like that. I mean, if our presentation would be like this, this is the amount of volume of solid and the remaining part is the volume of void, then the value would be less than 1. And it can be equal to 1 when the volume of void is equal to volume of solid, which is also very much possible. And it can even be greater than 1 when the volume of void is greater than volume of solid, which also can be which also is very much possible in real life. Okay, so it cannot be equal to 0, and it can be less than, it can be greater than, it should be greater than 0, and it can be less than 1, it can be equal to 1, or it can even be greater than 1. So don't be surprised if you see a value of void ratio more than 1 in your real life. So almost a similar question now. If E, or the void ratio, is equal to 0.5, what is the percentage of void? Okay, so if E is equal to 0.5, again the ratio is 1 by 2. That means the volume of void is 1 when the volume of solid is 2. Okay, so if we now fill in this three-phase presentation, so the volume of void is equal to 1 when the volume of solid is equal to 2, right? Is equal to 2. So what is the total volume then? Total volume would be 1 plus 2, that means the total volume would be 3. Okay, so the percentage of void now would be 1 upon 3. If you compare with the total volume or the total mass of soil, then the percentage of void is 33%, and the percentage of solid is 67% when the void ratio is equal to 0.5. In the earlier one, if you go back to the previous slide, for n equal to 0.5, the amount of, or the percentage of volume void space was 50% when n is 0.5, and the void space percentage of solid volume was also 50%. But when void ratio is 0.5, the volume of void is 33% and the volume of solid is 67%. This is very interesting. Most of the people often, give the same answer. I mean, if the void ratio is 0.5, then percentage of volume, void volume is 50%, and the percentage of solid is also 50%, which is not true. It may apparently look to be the correct answer, but it is not. Okay. So our next definition of volume to volume relationships, it is also another important definition, is degree of saturation, that is S percentage, and it is denoted as volume of water present in the total soil mass. Okay, sorry, in the total volume of void. So it is the amount of water present in the void space that is given by degree of saturation. And the range, you can see, if there is no water, then the value can be as low as 0, and if this void space is completely filled with water, okay, then the range, the value can be 100. So it will vary between 0 and 100. And we have now another definition, that is moisture content, and this is weight to weight relationships. We have not yet gone into weight volume relationships. So this is now weight to weight relationships, and this is also very important definition, that is the moisture content. I prefer calling it moisture content rather than water content. Water means it is a lot. Moisture means, you feel moist and you feel watery. The difference is like that. So the moisture content is denoted by small lowercase of w in percentage, and this is the ratio. Now we'll go on the left side of this three-phase presentation. So it is the ratio between the weight of water and the weight of solid particles. Okay, and the value, it can be as low as 0 if there is no water, if it is completely dry, if your soil mass has soil skeleton only, if it only has solid particles, in that case the value of moisture content would be as low as 0, and it can be less than 100, it can be equal to 100, and it can even be more than 100. See, the degree of saturation cannot be more than 100, but water content, or the moisture content, moisture content can well be equal to more than 100. When would when would this happen? If the weight of water, if the solid particles, the weight of solid particles is too low, and the weight of water exceeds the weight of solid particles, then the moisture content can well be above 100%. Okay, and it can be equal to 100% or 1 when these two weights are equal, and of course it can be less when the weight of water is less than the weight of solid particles. Okay, right. And we have now we have one definition, in fact 2 definitions, which will involve weight volume relationships. So here in these definitions we will have both weight and volume. The first one is bulk or moist unit weight, that is denoted by gamma and is equal to W by V. That is the ratio between the total weight and total volume. Okay, so that involves everything. I mean, solid particles, water, and air. I mean, we can easily forget about air. So this definition, bulk or moist unit weight, it definitely involves water in the soil mass. That is why it is called bulk, or to be more precise, I would like to call it moist unit weight because it involves water. And when you call moist unit weight, that means uh, you are referring to the presence of water in the soil mass. And then we have the other definition, of course, which does not involve moisture or water in the soil mass, that is the dry unit weight. That is the ratio between the weight of the solid particles to the total volume of the soil mass. Okay, so that doesn't involve any water. And of course, by definition and from the very understanding of the three-phase presentation, if you look at the definitions, definitely the dry unit weight will always be less than the moist unit weight. Okay, so now let us try to solve one problem which are very commonly given in the exams, or you'll have to encounter in your real life, in your professional life. uh, I'll show you how frequently you have to deal with three-phase presentations and weight volume relationships in my later lectures. So here, say we have the total. We know the total volume of a soil mass, V. Okay, so this is given 1.2 cubic meter, and the total weight is also given. And also, you are told that the moisture content is 18.6%, and the specific gravity of soil particles. We know the definition of specific gravity from the knowledge of physics. It is equal to 2.71. So you're asked to determine the moist density, dry density, void ratio, porosity, degree of saturation, and volume of water. Right? So if you have gone through the books of soil mechanics, you must have noticed that there are a lot of various forms of relationships tabulated in many books, and you have to. It's very difficult. I mean, I could never manage to memorize all these relationships, and in most of the cases you are not allowed to sit in the exams with open book. So I never tried it. I never tried this approach. I always tried to resort or to use my basic understanding of soil mechanics and the basic definitions. If you have understood the basic definitions, if you have already understood the inner meaning of this three-phase presentation of soil mass, then you would be easily able to solve this problem without using any kind of any of these expressions tabulated in books. So let us see how we can do with that, solve the problem without using any expression, any complex expression. So let us do the weight calculations first. So what you will always do when you get a problem like this, you will have to fill in all the values in your three-phase presentation. Here in the problem, you are given only two values, that is volume 1.2 cubic meter and the total weight 32350 kg. But you are not given this volume of solid, volume of water, volume of void, and weight of solid, weight of water, or there is no question of weight of air. So what we are going to do now is we are going to fill in this phase diagram. So how we are going to do? We are given water content value of 18.6, and we know the definition, basic definition. This is, at least this thing you must not forget. Okay, so the definition is weight of water to weight of solid, and that should be equal to this. So that will give you an expression of weight of water in terms of weight of solid. Now you know the total weight means the weight of solid plus weight of water. So you are going to get weight of water in terms of weight of solid, and you know the total weight, right? So that should, by using this small little expression that you have already developed, okay, you should be easily able to calculate the weight of solid as 2350 divided by 1.186, and that should give you 1981 kg. Let us put this value here. So this is the first value you have obtained. Okay, similarly, you can now get the weight of water, and weight of water is this total weight minus this much, okay, weight of solid, and that should give you the weight of water, okay, and that is also written here. Now let us do the volume calculations. So this, on the left side we already have W, Ws and W, all these are filled in, so we are going to fill in all these values now. So volume calculations, first of all let us try to find this volume of water. Can we find it? Yes, because we know the weight of water, and also we know the unit weight of water from the basic knowledge of our physics. So 369 is the kg weight of water divided by the unit weight kg per meter cube, and that should give you the volume of water. Let us write this here, okay. So now you have on the right side you have this value, the total volume, you know the volume of water. Now let us try to find this volume of solid, and can we do it? Let us see. Volume of solid is equal to, similarly it is the weight of solid divided by the unit weight of solid. Weight of solid is already known. Unit weight of solid is nothing but the specific gravity times the unit weight of water, and that should give you this. So 0.73 cubic meter. Let's put this value on the right side, okay, here. And the total volume is known, this one is known, this one is known. So what should be your total volume of void? This total volume minus the volume of solid, that should give you the total volume of void, okay. We are not interested to know the volume of air, because we don't have any definition, weight volume or volume definition which relates volume of air, okay. Now if you want to find your moist density, all these things, I mean, once these this three-phase diagram, all the values are known, you can find anything. I mean, that is a piece of cake now. So moist density is W by V, okay, you have W, you have V. Dry density is Ws by V, so this is Ws and this is V, okay. Void ratio is this, okay, 0.643. The porosity, N, is volume of void divided by V. Everything, all the values are known, so you can easily. Degree of saturation is S percentage, is volume of water by volume of void. I'm sorry, probably I have made a mistake here. This should be volume of water to volume of void. If you put the correct values, please do it yourself. 0.369 divided by 0.47, that should be very close to 100% or 80%, okay. So please make this correction here, use volume of void, and that value should also change. And the total volume of water is of course known, the total volume is known, that is 0.369 cubic meter. So you are asked to determine all these things, and you have done it, okay. And you have done it without using any derived expressions. That is the beauty of this part, okay. So you don't have to remember too many complex expressions and all these things. Just remember the basic definitions and try to understand what you are actually doing and what this three-phase presentation of a soil mass really means, and what should be the ranges of the values of these parameters. For example, just have a quick look and check. I mean, dry density has to be less than the bulk density. Dry density here is definitely less than the bulk density. That means, that gives you an idea that probably you are not going wrong, okay. And the void ratio is the ratio between the volume of void and volume of solid, and this is the porosity, volume of void, and the total volume. So porosity of a given soil cannot be more than the void ratio of the soil, of the same soil. And degree of saturation, just get it corrected. I'm sorry that I made a mistake here. I hope this is good enough for first lecture of soil mechanics. I'll come back with more interesting and intriguing kind of lectures in future and very shortly. Just subscribe my channel and try to feel what you are listening to and what you're learning. Thank you. Thanks very much.